Hello, everyone. We are live, hopefully. The cat was on my lap, and now he's getting off. If you're watching this after the fact, the stream's pretty chill, so check the notes doc down below for time codes to all the different stuff that we end up talking about. Definitely live. Thanks, Keith. We'll get going here and have a good time. I'm gonna pause my other video here. It insists to send me the video back down. Hey, Jason. Yeah, we're hanging out. Hey, Bruce S. Yeah, should be a good one. Pretty chill. Spooks in the cat cam. I almost kicked him out, but it's not as hot, so can have it. We'll get going in just a couple minutes for those of you who are like, why is he just talking? Although I think that's more and more common. Lightning storm. Ready to chill. Yeah. Hi, Mr. Certainly. Keith EE asks, how's the smoke there? It's gone. We only actually had it maybe 2 or 3 days, which is better than last year. Last year we had it for a full week. But yeah, it's gone. It's fine out now. It's cooler. It's only 72 in here. We'll attempt to be wonderful. Hi, Hamslab. Hope I am well. I am well. Yes, thank you. Been eating a lot of delicious tortilla soup that I made earlier in the week with corn from the garden and tomatoes from the garden and jalapenos and peppers from the garden too. So I just spent I'm sure I smell all tomatoes because I picked a bunch of tomatoes after lunch here. Well, now I'm hungry. Sorry about that. I know for some of you it's probably closer to dinner time, but I always eat right before I always eat before I stream because I'm not that pleasant when I'm hungry. So it's better for me to have eaten, and I've got water, and I've got water bottle too. Haha. Yeah, Phil's in the chat, says happy 5 years. First email to us 5 years ago. First email from you. Yeah, that was so exciting. Bruce made a Spanish tortilla, which is not a tortilla. It's an omelet of sorts. Hi, Dexter. Thanks, PT. It's been an awesome 5 years. What really got me was I was like, oh, that means that I'm almost to the point where I left Google. This will very soon be the job that I've had the longest since I graduated college. So that's even more wild to me to think of that. And I was almost 6 years at Google, so it's pretty wild that CircuitPython is getting up there too. Hey, Doctor. Hi, Anthony. All right, should we do housekeeping? David's out again this week, I think, so notes will be a bit more limited than they usually are. I think that's Korean. Somebody typed in the chat Korean, but it doesn't auto-translate it. I thought YouTube might do that. Hi, Paul. Hi, Andrew. Okay, let's get going. It's going to be another chill week. There's a video of a bobcat kitten at Critter Care, which is definitely cute. Hi, Linux203. Hi, Kiba. Did you go to UW? I'm in Seattle, by the way. I did go to UW. I got my computer engineering degree in 2009 is when I graduated. I first heard about MicroPython in college and CircuitPython a bit after. It's awesome seeing its growth over time. Awesome. Yeah, see, I hadn't heard of MicroPython until Adafruit was like, do you want to work on it? And I was like, this is amazing. I didn't know it was a thing. But I had obviously done a lot of Python, and I had just discovered how awesome embedded is. So it was perfect. It was really perfect. It was all just a very happy, right place, right time for all of us. Okay, let's do some housekeeping. And I'll try to take timestamps like I did last week. So hello everyone, my name is Scott and I go by Tanu Online. Forgot to write what I was time coding. This is a deep dive. I do these every week at Friday at 2 p.m. This is a chance for me to hang out and answer questions. It's a chance for me to show the work that I've been doing, regardless of like how deep or technical the work is. That's why it's called a deep dive. I work for Adafruit. Adafruit does open source software and hardware based out of New York City. I work remotely for them, so I'm in Seattle. So if you want to support me, and you can do that by supporting Adafruit by buying stuff from adafruit.com. Last week we noticed, I think it was last week, we noticed that like macro pads were in stock, for example. So buying those supports Adafruit, and they pay me to work on this stuff and pay me to stream as well. So feel free to do that. CircuitPython is usually what I'm working on. It's an open source version of Python designed for microcontrollers, which are these little tiny inexpensive computers that are mounted on these printed circuit boards. So you'll see here, there's a clue, and the black is kind of the circuit board. So a microcontroller is a really tiny computer, and here it's under this lid. And it's like, 100 megahertz-ish and a few kilobytes. Well, portions of a megabyte big in terms of RAM. So yeah, Minnesota Mentat says it feels like Friday. Yeah, so deep dives are on Friday at 2 p.m. Pacific. So yeah, typically we go for 2 hours or more. So if you have questions, I'm happy to take them. I think we'll kind of bounce between different topics. And yeah, if you want to chat with me and a lot of others, we have an Adafruit Discord server, which you can join by going to the URL adafru.it/discord. That's what the middle box here is the Discord chat. And the kitty, who's now back. Last week it was so hot, he wasn't up here. His name is Spook. He is epileptic, so he has had seizures during the stream, but not in a long time because he's switched meds and he's doing way better. But I just like to give that caveat just in case. And I think that's all the housekeeping there is. Good morning, Rod. Roger says the cat looks very relaxed. He should. He was just on my lap wanting pets, but I was like, dude, I can stream and pet you at the same time, but not necessarily ideal, I would say. Yeah, hopefully he won't lick his butt, which he's definitely done on stream before. Doctor says, I wish I could have skipped college and just worked. Some people do that. Keith says, there's a lot about my college life I wish I could redo, but I was fortunate enough to loosely aware of MicroPython and from that CircuitPython, and that's something I loved from my time back then. Nice. I liked college, yeah. I don't wish to go back, though. I'm like so happy to be done with school. I learned so much just on my own. Ask Patrick W says, hey, we all made it to another deep dive. Hey Patrick. And shout out to Patrick for posting all of the notes in the repo. So if you just joined our deep dives, we have this repo, and let me switch to the desktop. So on GitHub, we have this deep dive with Scott repo here, and it's just like the CircuitPython Weekly. We've got all the past notes. And Patrick wrote this awesome script that actually annotates all the time codes with the link to the YouTube. So consider this like very basic search. So if you ever wanted to like try to find when I talked about something, you can clone this repo, or you can actually just search in this repo for, let's see, if I search for like USB. So here we can see like some things that we talked about and the time codes. And then if we wanted to go look at it, we could say like, here, and then here's USB, so we could click through there. So yeah, thanks to Patrick for that, and thank you, even though David's not here, DCD. He's a huge part of why these notes are so good, because he usually does it. So he's taking some time off. He'll be back. But yeah, so thanks to Patrick for doing that. It's always great to see the PRs come in and take a look at that. Minnesota Mentat says, sure, appreciate that effort and diligence. Yeah, I take coarser notes kind of when I'm doing it myself. But yeah, hi Neradoc. All right, well, I guess I haven't seen any questions go by, so if you have questions, feel free to ask them. Otherwise, I would. Hi, Patrick. I thought I would say, or I would start by going over the two main things I was working on this week. So the two main things were, well, on Tuesday I met with Antonio. Oh, let me take a time code. Speaking of time codes, Unicode. Keith says, did you get any signals from the Wii balance board? I haven't poked at it. I'm kind of hoping somebody will figure it out and then email me. I haven't poked at it. I've been very distracted, and I think I'll cover why I've been very distracted later in the thing. It's not Adafruit related, which is why I'm trying to like minimize my interest. But I have another project that has sucked me away, and I'm about to get nerd sniped again, I think. Just poked it and hoped. Yeah. Yep. I'm not sure how to get it going. Maybe it needs to be inverted or something. I don't know. Like, clearly you can do it. Like, there's no way. Yeah, so we were talking about this last week, is that the Wiimote controls have UART, TX, and RX on them in the battery compartment. So we were trying to figure out how to talk to the remotes over the UART, TX, and RX. So if anybody knows about, and that reminds me, I do have a topic I want to ask people about too. But first, I already took a time code. Let's talk about this Unicode stuff first. So I met with Antonio, and I met with did you say nerd sniped? I did. Nerd sniped is this idea of like somebody brings up an interesting topic and distracts you in a nerdy way. So okay, so Trevor and Antonio and I met on Tuesday to talk about the apps for the BLE workflow stuff. There's really good progress. In fact, I need to test. I just got invited to the test flight for PyLeap, so that's really exciting. And maybe I'll try to do it. I'm not sure I have it on my iPad yet, but I would like to get it going on my iPad. I need to try it today. So then, one thing that Antonio said was that he had a problem with CircuitPython when trying to write a file that has Unicode in it. And I was like, oh, like one thing I like about mobile experience is that like you can use emojis in lots of ways that you wouldn't before. Because I guess I think that's cool. I'm like on the edge of what age that you think that's cool. I showed previously that I was doing like code.pys with variable names that were emojis. So I'm all for getting really good Unicode support in CircuitPython and the stuff around CircuitPython. Emojis are fun, but the reality is that it also gives us, it kind of ensures that we would work across languages and things. When you see me working on CircuitPython during the day, yep, you got nerd sniped. Yeah. Yeah, so Antonio had said like, oh, Unicode doesn't work. So I dug into it and I've fixed it. Or I'm in the process of fixing it. So I thought I'd just do kind of a PR review like I had before. And we should actually check the CI too to make sure it's actually working. So there's this turn on Unicode for FATFS. So one of the first things is that there's a switch in FATFS that allows the API for FATFS to be Unicode. Otherwise, it has like some very old kind of historic encodings instead. So that was one of the things that I did. And then because I was in there, I noticed that we had exFAT support turned off. exFAT is really common for larger SD cards. So it's not going to be on in all builds, but exFAT support will be on in more builds, which I am hoping will kind of like reduce the number of people we hear from of like my SD card's not working. If we can get more, if by turning it on, we can get more support or better support for SD cards with exFAT support, that would be awesome. So I found one. I found a number of bugs with this Unicode thing. If you don't know, we also have a glider repo. So glider is the like very basic, just send a file to and from the device. It has nothing to do with CircuitPython. It's all about just like this BLE file transfer protocol. And so what we can see here is that there's this PR that I did, and one of the tricky things with Unicode is getting your lengths right. So Unicode characters are variable length. ASCII is always 1 byte, but Unicode is not at all just 1 byte. And so I found this error in the Glider app where this is the code that's in. So in the BLE, I'll just pull it up. So the documented file transfer protocol is here in the repo. And generally, if you see a lot of these, I think a lot of these or all of these commands take paths. And when you're given a path, you're supposed to provide a 16-bit number encoding the encoded length of the path string. So there is the subtlety when you're dealing with Unicode strings of whether you're counting bytes or whether you're counting characters. Because in Unicode, in UTF-8 in particular, you can have variable lengths of variable numbers of bytes per character. So I tried to be specific here to say that like it's the encoded length, not the character length, which is why I had to do this fix here. So what the bug was is that path here is a string. So path.count is the number of characters. And then you'll notice like previously the data section was already doing path.utf8. So for all the lengths being sent from the iOS app, you have to do path.utf8.count. And that will be the count of bytes, not the count of characters. So that was like one of the first things I found was that like the way that I tested it is like on the CircuitPython side, I just put a print. I said, print out the path that I'm getting. And when I did that, I noticed that it wasn't perfectly correct. Like it wasn't printing the correct path, which meant that like something was broken between the app and like printing it out. And I looked at the count or the length and it was wrong. So the reason it wasn't showing right is because it was considering it was too short. So yeah, this was one of the bugs. And then I turned it on in CircuitPython and FATFS. So we use this library called FATFS. Does that mean that you're doing the encoding twice? Yeah, potentially. Although I kind of assume that it's stored internally as UTF-8 as well. Like that's kind of the case in CircuitPython is like it's a string and it's encoded in UTF-8. So like doing that work to encode it to bytes for that is like just a copy. So this is the module. We use a derivative code from this module. So this is really well documented. You can see I was actually looking at like the changes that they've made since we've updated. Damien made like an object-oriented version of this library that is used in CircuitPython and MicroPython. So I flipped the switch so that all of the APIs for it would be UTF-8. The encoding in the file system itself is like a different, slightly different Unicode style encoding. So it does have to change it a little bit, but it's not too bad. It does change the file size a little, which is unfortunate too. So this was one of the fixes. Good morning, Unexpected Maker. And hi, Christian, too. I didn't say hi to you yet, I don't think. So let's take a look. One of the things I had to do, and we'll see this a lot, is I had to reduce the size of everything. And so that's why it's still not merged in, is I was just having like build issues that I'm working through. So we'll take a look at those too. First up, I had to add some MP fall through designations. This is the compiler does a check if you have a switch statement and if a case doesn't break out and goes to the case after it, it has a way to check to make sure that it's deliberate. So we have to mark it as fall through. I had to add these because I turned on Unicode support, I had to make sure I like it was compiling a new portion of the code that it wasn't encoding before. So here's me plumbing it through. I just say like, oh, it's no longer just 0. We allow this MicroPy, FATFS, LFN, Unicode. So the LFN bit is that FATFS actually stores 2 copies of the file name. The original version of FATFS only allowed like 8.3 encoding, so really short file names. But then they came up with this kind of hack that ended up getting patented, and it was so long ago that the patent's expired now, which is great. But the LFN is the long file name. So in the docs, you'll see SFN, which is short file name, and then you'll see LFN for long file name. And it's kind of a hack because the file name gets put in the directory structure or something. But that's why this is called LFN Unicode. So that's that. So here we see that I'm just doing a lot of board size optimization. So one of the optimizations for code size that we can do in CircuitPython that's really handy, and this is only for the SAMD, but for the SAMD we can do these defines to ignore pins. The SAMD has a 12 byte structure for every pin that you can be used, and that's what stores the information about like how circoms that do I2C and SPI and UART are connected to it, what timers are on every pin, that sort of stuff. So it's 12 bytes a piece. And so if we need to save some bytes, what we can do is we can do these defines to basically omit that struct from the code. Hi, Johnny. Someone told me that to this day, Windows is still 8.3 internally. It could be. Yeah, so both things are available. It maintains both things. It just prefers to show you the long file name. So yeah, so these are just pin things. So I looked up like the data sheets and ignored pins. So that actually got a lot of space, especially for these datum boards, which is great. So then I had to do a little bit of like, oh, for this SAMD51 board that uses internal flash, like we need the space, so don't do exFAT. Turn off get pass as well. Get pass is a new module. Generally, like I try to turn off the things that like people won't be using because it's new. This is a minor thing for audio core. Yeah, and for SAMD21 boards, for all SAMD21 boards, we're turning exFAT off. Along with the small NRF boards. The exFAT support is like 3 or 4K, I think. So it's like when I did these builds, they had no chance of fitting these ones with the exFAT. I also added this CircuitPy MicroPython Advanced. So there's a MicroPython module that we have on, and it has things like heap lock and unlock. It has stack usage statistics and stuff. And I wanted the ability to turn those off. So here's the config changes. So I made code pages generally ignored. It's not fully ignored. But setting the API to use UTF-8, which is what we use internally. The CircuitPy MicroPython Advanced APIs are now behind the full build. The only thing in the MicroPython module in the non-full builds will be the const, although it may not actually be needed. But yeah, we still want it. And then exFAT is on for full builds by default as well, which I think people will be excited about. So here's the change I did to turn off those advanced APIs like stack use, heap lock, memory totals, optimization level, that sort of stuff. Like that's pretty rare that you're going to need that. Is Scott not categorized into ladies and gentlemen? And Scott, oh, that's fine. I don't mind. I don't need to be a lady or a gentleman. So once I got the file name from the app into CircuitPython correctly, like my debug print looked okay, I opened it up in the terminal and I just did, like, the file was written, it looked all good. So, and in fact, on CircuitPy, I showed it as well. So I was doing like, hello, smiley, smiley or something. And then, Scott does Scott. Yeah. What I did was I did os.lister and I noticed that it wasn't printing correctly. What it was doing is it was escaping the smileys. So it was like, hello, \u, number, \u, number, for the Unicode encoding. And I was like, oh, that's weird. And I tried it in CPython, and CPython printed it as I would expect, meaning the printable Unicode characters got printed. So what I discovered is by digging into MicroPython, this is all MicroPython code, CircuitPython, is that it was just, I am Joel. What I noticed is that this is the print, uniprint quoted is used for like the repr version of the string. So if you did print of a string that has Unicode in it, it would look okay. But if you did just that thing and it does a representation of it, it would escape everything, even though CPython doesn't. So what I found here is that this escaping was doing the only things that it printed verbatim was ASCII characters between 32 and 126. So I deleted that because I wanted the last case to actually be to print out the full character as is. So that's the else clause now. So all of these previous clauses are all of the things that we need to escape instead. So this test here is now inverted. So this test here is all of the ASCII characters that are considered not printable. So that's like your return character and your tab and some other ones. Control C, Control D, those sorts of characters. So it's not even ISO 8859. I'm not sure what ISO 8859 is. It reminds me of character encodings, but I'm not sure what it's referring to. Yeah, so this prints out, it uses the \x form to escape characters, ASCII characters. And then these are ranges here, where they're Unicode ranges that I'm also escaping using lowercase u. Lowercase u is 2 bytes. And then there's a 4-byte version, but we don't escape any 4-byte version anymore. Basically, I wanted to assume, so actually, let me just follow this link here. So I was curious about CPython's policy for this. And I'll pull it up. All Microsoft stuff prefers 8859. So I found this cool comment in the CPython code that says, returns 1 for Unicode characters to be hex escaped when repred, 0 otherwise. All characters except those characters defined in the Unicode character database as the following categories are considered printable. Oh, 8859 is 8-bit ASCII. Comes in different flavors. We use 8859-1. Yeah, so I think this is important for folks that that are like new to computers. It's these sorts of standards that are the thing that convert numbers that the CPU deals with to like representations of things, like letters, right? Hi, Pierre. Did I say hi to Randall? Hi, Randall. And Sadie. Yeah, so this was really interesting. This got me looking, like trying to figure out what category every Unicode character is in. Because I kind of had a couple thoughts on how to do this. I had this test script where I was like, you know what? I can just generate all the characters and see what it prints out. but then I was gathering it into ranges that were not printable, and there was a lot of stuff. There was a lot of like 1s and 2s and 3s and 4s ranges, and it was like, I am not going to write the world's largest if statement to be able to do this. So I really wanted to like figure out exactly why or what policy we should have instead in MicroPython. So basically what it came down to is like control characters, they're in ASCII, and I basically did those. But private use is like private use characters are not really anything interesting. So I kind of just wanted to assume like you're not going to use private use characters in strings in CircuitPython or MicroPython. So we don't escape those. Not assigned. These are the ones that these are called reserved. And maybe let's find the Wikipedia. Wikipedia has an awesome awesome chart, not this. Unicode blocks. Where did I find it? Dang it. Unicode. Oh, wait, here we go. This gets me there. So this is really cool. So here's the Unicode character reference. Oh, it's in Wiki Books. Hi, Fed82. This is really cool. So I was using this. So all these gray boxes, these are the ones that are unused right now. So my test script that was going through everything and seeing whether it was printable or not would get a range of like 3 characters that are not printable. And I'm like, I can't do all those checks. And you'll see that even these characters here are being printed in a weird way by the font that I have. So these, this is the range that I am escaping. And so if you hover over it, it says this is a 3 per M space. So these are different lengths of spaces. So in reppers, these are generally escaped so that you can see exactly what is what. So there's like paragraph separator is another one that gets escaped. And if you see here, this is exactly what this is saying. Like the line separator and the paragraph setter get escaped. And then like the only type of spacing that is not escaped is the ASCII space. So that's kind of what my decision was, is like, we'll only escape these ones that people are probably going to actually run into. And then these C control characters are the ones in the like lower single byte ASCII range, I think. If we look at this wiki books, I mean, this is awesome. It's pretty neat. So like Braille. I did, there's one unprintable character that has to do with like Egyptian hieroglyphs, and I was just like, okay, I'm not going to support that. But then you can get up to here, and this is like selector supplements. What does it say? Variation selector, and then unassigned. So like this is a huge range that we could like choose not to, but because it's like unassigned, like why bother checking for it? If like assuming your UTF-8 is correct, like we're not going to have that. Unicode is the same as ISO 8859 for the first 255 characters. Yeah, so if we look down here, if we click this first set, like this is, so see, this is the C0 controls. So those are the things that we do escape. And then it's basic Latin and Latin supplement. So these first two large chunks are those single byte characters. I would vote for the Unicode range from 2800 to 28FF to be supported, says Thomas. Braille. I think it should just work in CircuitPython. Just got my board supported by CircuitPython and found a whole new rabbit hole to spend my time on. Awesome. Neat. Hieroglyphs, Egyptian, and Mayan plus cuneiform. Yeah, so what this change is doing is that whereas when it was repred in CircuitPython previously, it would get printed as the escaped version, it will now just show you the character instead. And I think that Thomas 2800, I think we just went by it, didn't we? Wait, that's 28,000. 2800's here. This is a great reference. I should bookmark it. Here, save. And you know what? Let me put it in the notes too. Unicode character reference. I'm doing a great job on time codes, but we're talking about. So I think Unicode's really important, which is why I kind of wanted to dig into it and make sure that it worked well, which also meant that I really wanted to make sure that all of our builds had this enabled. Like all of our builds will support Unicode and FATFS, which is why I turned it on, and I like had to rewrite and find some space for things, because I really wanted it to be a universal thing. Not exFAT. exFAT's different, but the Unicode support I wanted to turn on for everything. Oh yeah, Thomas says for Braille. So yeah, here we've got all of the Braille characters, which are awesome. So you can hover over it and say like pattern dots 1468. Johnny says, now we need megabytes of flash to store the full Unicode font maps. Yeah, that would be cool. That's basically what like Joey did for the open book. Like Joey did a lot of work with Unicode for all of the open book stuff. It's really neat. And his solution was basically like his solution was basically to have a second flash chip just for the flash to store the fonts. Yeah. I do quite a bit of transliteration, a little bit of translation. Sweet. That's awesome. Yeah, so this is really important to me, and that's why I was like, if we're gonna turn on Unicode FATFS, we need it everywhere. And this switch to the way that we print it out it will be true everywhere as well. So that's this is the CPython version. Or no, that's not the CPython version. Where did it go? So CPython, they have this thing of like, they just have this database of all of the characters, and then they just see like, oh, is it printable or not? So they can get really fine grained, but I didn't want to store all that data to do it. So instead, there is this cool CPython Unicode database. What's the module called? Unicode data. This is really handy, really handy. This is what I did, is I wrote a script to take a look at this and just see stretches of different categories, because once I looked at this comment, I could see all the different categories that are not printable. And therefore I was like, okay, well, how many different ranges of things are there? And the one that's like the reserved category is a lot of sporadic stuff. So it's like, first and foremost, I'm not going to do that. And then there were these other things, other characters that were pretty like off by themselves. I was like, I don't really think I need to support that. Like a few control characters for different languages. The worst case, like if I choose not to escape it, the worst case is that it changes the way it prints out. It still doesn't like remove it or anything. So yeah, this Python module is really neat. It's a standard library module. Of course, they have that data, so they might as well expose it. But pretty neat. I went from like figuring out like reverse engineering what it printed out or not to being able to just look character by character what category it is, because you can just give it a character and ask what the general category is. So that was neat. Yeah, so what I chose to do in CircuitPython is that I said these settings approximate CPython's printability. It's not exhaustive and may print unprintable characters. All ASCII control codes are escaped along with variable space widths and paragraph designators. Unlike CPython, we do not escape private use codes or reserved characters, because we assumed that like you had to get the Unicode in there somewhere, and if it's corrupt, then you have bigger problems. You can always print the underlying bytes as well, if you want to see the byte representation. So yeah, so I had to switch this, and then OS lister worked, which is great. So anything that uses the representation of a string would be correct. I had to fix this test that was using invalid characters. I think it was invalid characters. And I added this new test for repr, so using 1, 2, and 4 byte wide characters in it and making sure that it prints out and represents the same as CPython does. So yeah, that was one of the things. Did you block my message? Rude. I don't know what you're talking about. Oh, I guess I didn't see it. Maybe it... Yeah, I don't see any others. Oh, cool. And about 3 Costa Rican indigenous dialects. Egyptian and quite a bit of Sumerian. That's amazing. I'm so bad at languages. All right, well, let's take a look at this. The CI is still going, but it says 2 have been failing, so I wanted to look at that. And I also had a question. Not you blocking it, YouTube. Yeah. Sorry. Not in my control. So I was having problems with fitting code size. So it looks like we're still having code build size issues. 40 bytes. 40 bytes. Ugh. I have one thing up my sleeve that I don't really want to do. And then this is 144 bytes, so that's still a lot. Bummer. That was the Nano 33 IoT. How much did I... Got really sick from vaccine number 2. Better than getting COVID, though. Are you feeling better, Mark? I'm wondering how sick I'll get from vaccine number 3 if we get vaccine number 3. If you don't show us what's up your sleeve, how will we learn to do the magic tricks? So this is the challenge with these problems of having code size, is that the moment you free up the space, people fill it. And the thing I have up my sleeve is that I'm not feeling good. Sore arm and feverish. Oh, I'm sorry to hear that. Are you, how many hours after your second dose are you? Because I definitely did feel like run down and weird. Bruce says, I felt like that for a few hours, Advil, and back to bed. 24 hours for Johnny. Twitter message length comes to mind. If you change it, people will fill it. Vaccine number 2 was the sickest I've ever been as an adult. Wow. Still better than COVID, though. Hoping dose 3 will not be as bad for me. Yeah. Sorry to hear that. I'm gonna go get the flu shot here next week, probably. Because they just came out with the flu shot. Aww. Mark says, also, my amazing uncle died on Tuesday from COVID. He was vaccinated but had pre-existing conditions. It was 8 hours after that it came. Now I'm about 36 hours. Oh, I'm so sorry to hear that. Skir says, I'm hoping it is be as late as when I actually had COVID. What hardware is this for? Steel Blue Vision asks. This Unicode stuff is for all of the CircuitPython devices, which is a lot of different stuff. If you go to circuitpython.org/downloads, this Unicode stuff will apply. FATFS Unicode support will apply to all these devices with CircuitPython 7, and the exFAT stuff will apply to most devices, those that we consider full builds, which are basically like not SAMD 21s and a couple others. Maybe they'll combine the flu and the COVID in one jab. I don't know. Should stop writing my English sucks. No worries. No problem at all. Yeah, we feel for you. Sorry, folks. Get vaccinated if you can. If or when you can. What was I doing? Oh, so the thing up my sleeve for code size is, maybe let's talk code size. The thing I have up my sleeve is that whenever I build, and maybe I talked about this before, oh, that's spoilers for my non-Adafruit project. So if we do @mlsamd make Borg Arduino 0 Arduino, what is it? Nano 33 IoT. Yeah. So if I build this, it doesn't run out of space. Wow, 5 to 7 days, Dylan. That sounds rough. mRNA flu shot that might be combined. Better cell reception. Yeah, so if I do that build that failed with like 144 bytes free on mine, it succeeds. And Dan figured out why this is. It's because I don't use the version of the standard library that ARM releases. I'm using the version that Arch Linux builds, and when they build it with -OS, which is optimizing for size, whereas the ARM build is -O2, which is probably faster but larger code size. So this is the trick I have up my sleeve. The reason, well, one, like, it might be a lot of work, but also, like, the moment we open up these 1200 bytes, like, people will fill it. So I'm kind of like waiting as long as possible to actually set that up. Like I've gotten really close. Now I had a question that I thought actually folks might know. So I was getting desperate for bytes. My partner was coming in and asking me, she's like, just wanting to chat and stuff. And I was like, do you have extra bytes you could lend me? Like, I want to find extra bytes. So this is a program called Okteta. It comes on KDE. And it's used for viewing binary files. So if I open recent, I have this full.bin. Now ignore the first 2K of this. I just added 2K of zeros to get the offset to be correct so that I could compare it to the firmware map. But I was looking through this. So here's CircuitPython's core. And if I page down, basically what I was trying to look at is like, are there any places where there's a lot of zeros that I could figure out why there's a bunch of zeros, so that I could delete them and make our library smaller. And let's see, I'm kind of curious to see. So I found this pattern. And I wondered if somebody, well, there's some. Those are pretty long ranges of just zeros. Like, why in the world would we be storing a bunch of zeros? Not as cool. So the way that we can figure it out is that we pull up Sublime Text here. And this full bin is for a build of Arduino 0. I hope it's the same one. Otherwise, I'd have to redo this file. But if we do build Arduino 0 firmware elf map. Looking for sequences of zeros, that's really scraping the optimization barrel. I tell you, we have been in this like optimize the firmware size business for many, many years at this point. And that's one of the reasons you'll see us be so aggressive. How aggressive we'll be when we move compiler versions, because generally GCC's gotten better and the code size always goes down with newer versions. So if you delete the zeros, won't that change the way CircuitPython operates? I can't just delete the zeros. That would like shift the location of everything. But what I can do is I'd like to figure out why those zeros are there, right? Why are we storing this range here of zeros? Like, there's a way to have memory zeroed in the first place. Oh, and this gives me a clue. Look at this, CircuitPython HID. These might be USB descriptors with a bunch of zeros in them. I'm not actually planning on doing compression. Keithy says, woo, compression, that's what I love. I'm not planning on actually doing compression. What I would like to find is I'd like to find places where we're storing zeros where we don't actually need to store them. Because there's the BSS section, which is an area of RAM that starts at 0. So if there's something that I'm storing that is actually like mostly zeros, like maybe what I can do is move that large thing to the zeros area and write some code to just like plop the one value in there that I need. Higgins says, is there a trick to getting a MacroPad to show up as a device in Linux by plugging and unplugging or hitting the reset button? Make sure you're using a USB cable that is known to be good. That is almost always the problem, is that the USB cable is bad. Oh, it shows up in dmessage, just not as dev in my file browser's connected storage device. You might try it in different USB ports. There is a bug on this in the silicon for the USB stuff. But yeah, this gives me a clue. This CircuitPython HID string here. So this is a C string. So this is what I would expect. Hi, Beata. And there's a lot of zeros here. So if I do 2C500 and I go, I'm cramped for space, unfortunately. Like, can I turn off word wrap? View word wrap. Yeah, that's better. So it is a debug build, so there's all these debug macros. But in the map file, at some point you get to the point where there's actually addresses. So if we keep going further down, we're trying to go to 2C. 2C5. I wonder if this is old. This must not match up because 2C5 here is a pin definition. 2C5C. 5C. Yeah. Product name. 2C5D0. Yeah, this doesn't look like it's exactly matching up. Let me just do it again. Let's make that full bin. So what I did is let's rm full bin, and I did that. Let's see if that changes it. Huh. I noticed that CircuitPython device serial numbers are nibble swapped between 6.3 and 7.0. Interesting. Do we care? It would make sense that it was like there's a lot of USB HID stuff that or USB descriptor stuff that changed. So I would bet that it was introduced then. Run length encoding. I'm not actually going to do compression. There's a lot of string compression already for error messages. Let's open this again. And let's go to 2.5. See. Oh, yeah. So look at that. That's interesting, actually, because this is 2.5A7. That still doesn't look like pin data. For some reason, I'm not... Oh, this is 2.5, not 2C. This looks like Q strings. So see all of these things like collections? So that's the string for 16-bit strings. Yes. Q strings could use the same compression as error messages. The problem is that Q strings are also added dynamically. So we would need to either be able to distinguish between compressed and uncompressed Q strings, or we would need to be able to compress them on the fly, which would save RAM. So a Q string is, if you look in CircuitPython's source, like if we just pull up, actually, let me take a time code because this is a great topic. Maybe we've talked about it before, but you know, we can talk about it again. Qster. So if you look in just like your shared bindings, top level, and look at the bottom. So this is your map for BLE. These are, if you do import underscore BLEIO, this is the thing that does the dictionary to look up stuff. And so we have these NPQ strings. And what that does is there's a script in the build process that looks everywhere for things of this form, and it mashes them all together. So it deduplicates all of these strings, and then it gives them a 16-bit identifier. So that 16-bit identifier is used to refer to that string everywhere in the code. So this table, this ROM map thing, like this value here is actually just going to be a 16-bit number, whereas in C, it would potentially be a 32-bit pointer to some other place. So this is, Q strings is a way to both deduplicate and save memory. So if we go back, you'll see that like there's just all these different names. So this is like the Q string pool. There's like data into this, and then there's also something else. You can see like module names like bin ASCII. And actually this 2.5A3. So let's go back to our map file and just make sure that like, because it's pretty obvious what that is. Let's just kind of correlate it with our map file. Did it end up getting closed? I have too many files open. It's right here. And I gotta turn the word wrap off again. Let's open it for good. Word wrap. So it's actually 2.5. This is not right. My offsets are not right. I wonder if that 2K that I added is making it worse, not better. Where is this Qster? 2A. Like there's this const adder and then there's this const pool. So there's all the pin names. This must be the pool. Or whatever the first one is. (2A87). I don't know why these aren't matching up. Does anybody know why these aren't matching up? It would be really nice if they did. Like, the very first thing is at 2000. And that's the vector. So if we go all the way up to why is that 800? Oh, is it not 2K? Oh, geez. Like, this is where the vectors are. There's debug strings in one of them. Are they in the other? Heck, they're not matching up because it's a live stream. You're assuming I had it matching up beforehand, which I did not have. What is the offset for 800? Did I just make it? I think I just had my file. Like, right, it's a 2K file, but 2000 is 8K. That's why it's wrong. Okay. I need 8K, not 2K. So I use DD to make the file. Okay, so now if I do remove full bin cat 8K. All right, let's reload this file. I should have checked that way earlier. Reload. Okay, so we got more zeros, which we expect. And now the non-zeros, which is the reset vector, is now in the right place. So if we now go back here to our Q string, const adder is at 2A374. Oh, I'm so excited to get this right. 2A 374. That's the attribute table. Now the pool is at 2A87. So at 2A87, we should have seen it. What is that? So this is really weird, right? Like, this is a whole lot of zeros in columns. So this is what I was going to ask about. Like, const pool 2A87. Look at all these zeros. This has got to be, what is that? 0 through F. That's like the hex table. C190. Yeah, that's right. Nibble to hex upper. That's what it is. The const pool is where you go to swim through your code. So I think this is matching up because that's certainly the nibble to hex upper. Good night, Dave. Thanks for hanging out. And plot a histogram of the bytes. Ooh. Yes, I could do that. So all of these look like these are tables. Like objects, global tables. So let's look at like C1E0. C1EC is this one wire IO module. One wire module globals is 16 bytes. Globals and globals table. All of these 2s are probably addresses, so this is probably an address. C1 EC. Oh, you know, that's what all these zeros could be. Plot a histogram of the bytes. I think that must just be pointers, right? So like this is the 64-bit version of the pointer, but if we're storing a regular pointer of a 32-bit, it's gonna have this top 2 zeros on it. So like each pair of hex digits is 1 byte. So having a single zero is next to 2 is actually not that surprising. And because those are just all pointers. So I think I answered some of my own question. So one thing I found is funny is that there's both padding, there's a padding zeros and a padding spaces, which has 28 bytes, which we could totally get rid of. Like, why in the world is that in Flash? Why is that in Flash? Should we save those 28 bytes? Thought my eyesight was getting worse due to the fever. Turns out it was just YouTube selecting 480. Yeah, it could be padding for alignment too, Christian. That's right. So I found this spot that was like... So there's like a name. But let me find what I was seeing before. This looks more like what I was thinking of. Yeah, but look at all that stuff. Look at all those zeros. It must be just pointer tables are pretty common. I think those strings are used in the format functions. Yeah. Yeah, those 2 strings for padding. I found this really weird case when I was looking at this yesterday. I wonder if these things without the zeros is actually code blocks. So like the things with lots of zeros are pointers, and then the code blocks are dents. And then it like frees up again. But this is where I was like, this looks funny to me. This region right here. Here is the thing that I was thinking about. Because look, it's CIRCUITPYTH. There's no ON. The word before it is possible, and it's all of these like 0 something, 0 something. This is like 16. It's 2 bytes a character instead of 1, which is really weird. So we're in 2F8. 2F800. So let's take a look down here. I was like, what is this? And can I make it smaller? 2F. So does somebody, yeah, I think this is the right section. Does somebody know what this is? What are these read-only datas? I don't know what those are. Compressed French error messages. They are chopped to pieces, right? They are chopped to pieces. And it is a French build. But why are they... Ghidra would be great for this. Peter, I've tried Ghidra, and I don't know how to use it, unfortunately. I would love to watch a live stream on how to do that. Like, that's what live streams are really good for. So did I go by the end of it? 2F. Oh, okay. 2F8 is not here. So 2F8, we are past 2F. Two F8D0 is the end of 8D0. What is this words? I think you're right. This words must be a compression thing. But they're not UTF-8 words. They're UTF-16 words. I guess that's by design. Oh, Hopper for Mac. Ooh, Patrick linked me to the thing, right? Copy link. Count of words by length. Haha. Impossible. It's very painful when you first start. Yeah, so I was trying to use Ghidra to reverse engineer the firmware of the Wii balance board. That's I was like looking at it pretty recently, and I was like, this doesn't seem right. Yeah, I can drop these files in Discord. CircuitPython ports mlsamd full.bin. CircuitPython was in that. Yeah, that's true. But why isn't it UTF-8 encoded? That's the thing. Arduino 0. It might be on accident. Elf map. And I'll send the UF2 as well. All right, so if you want to follow along, the files are on Discord, which you can go to by going to the URL adafru.it/discord. Okay, so how are these, what is the structure of this words table? Like, I do feel like I'm onto something still. Like, I don't know of a reason to have it. Thanks, Bruce, for posting the link. Make QString data. Bits per code point, iter substrings, length of words. values, const mchar values. But we're not looking at, what is mchar? Format. Values type. Oh, that is not what I mean. My chart. That's the one. C character types. I think I could put it in quotes too. Wide characters. Like, I get wanting to be able to support it. Multi-byte. I was looking at this. There's got to be a better way than mchars. It's lengths values. Wait. Let's take a look. This generates a file. Let's find that file. It's in build gen compression generated. Yeah. Yep. So look at this. This we do want a word wrap. So we've got a words table. Oh, values is also mchar. Type def, mchar. That's why I couldn't find it. mchar is a uint 16. Lengths, but these lengths could be bytes still. Let's indent this. All right, folks, I think, does anybody disagree with me that this is a place where we can win back some bytes? Oh, interesting. Pew Pew M4 has type def uint 8. This could explain why the French build is so much larger. Is that if the French build is using uint 16 to store everything. Compress word offset table scope. Is it just the error strings or does it go further? Yeah, so we only do compression on all translated strings, which is almost all error messages. But also that, yeah, so this is a French build. Can you tell it? I'm in the zone. I'm on the hunt. I'm on the hunt for some bytes. Now, how many bytes is this? I wish it would print it out for me. And these are 2 bytes apiece instead of 1. I think if we try something other than Huffman, we can get space. Don't knock Huffman. I don't want to change. I don't want to change any of the compression stuff. I just want to store how the words that it decompresses with are stored, right? Like, I'm not going to redo it all. Like, it's going to be iterative. But what I'm trying not to have is this. Like, let's see, how long do we think it is? Like, it's about there. It's about that block, and it's like 496 bytes. So we'll get about 250 back. Hover over words, and it might tell you how many bytes it is. What, is it that smart? No. There's no reason that the Python code can't print it out. So the question is then when words is read, text has correlation Huffman ignores. Well, that's part of the reason this compression is doing it over longer words. I also get Uint8 with French. French should use ISO 8859, so I see no need for 16-bit characters. Yeah, so I think it's time for us to actually start poking at the compression script and see how it changes things. So let's go to the compression script. I hope folks didn't want... No, it's not that smart. I hope folks didn't want to get to USB because I think I'm onto something and I want to get this PR out by the end of the week. Define compress max length bits is 8. So why is it Uint16? Okay, let's just rebuild. Okay, so actually let me copy the build. Arduino 0 firmware elf map. Let's just call it full map. Never know where a deep dive takes you. It's totally true. I'll have to change the title since we're not getting to USB, but it's kind of fun to... Oh, I wonder if... Okay. Good night, Mark. I hope you feel better. Yeah, VS Code does a lot. Indexing. Oh, look. The size changed. Are we in the wrong... Reload. So this is still Uint16. Christian says I'm getting Uint8. I'm on the Arduino 0 with this branch of mine. So why is it? All right. So I find the easiest way to edit this script is, let's see, where is it? We found it in here. It's pi make qstring data. Okay. So pi make qstring data. Okay. Here we go. Max ord. If max ord is greater than 255, bytes per code point. Estimated net savings. Where are we printing to? Not this file. Length count. It might be in one of the other generated files. So let's open those two. Build. I really need to delete these build folders. Gen header. Qster. There we go. So this shows us words 55. And these are all the words. Yeah, that looks right. That looks... So this is the Huffman table that we've got going. And length count values. Right, so I think it's that I turned word wrap off and now nothing is word wrapping. Lengths. We're like printing values twice. Oh, that makes total sense. But it doesn't make sense that we're doing it wholesale. Like, I don't see why we should store it as uint16 everywhere. We should be able to do it as UTF-8. Am I right? Oh man, I gotta close some of these. What do you mean by wholesale? Wholesale, I think when I meant it, I meant like storing all of the characters as 2 wide instead of only storing the characters that need the space. Cancel. We'll keep that. Although I fixed that bug. I fixed this bug. This was my figuring out how to the USB problems. But I don't need that anymore. Agree about UTF-8, but as a quick fix in the meantime, maybe find the probably one code point above 255 in the French translation and eliminate it. I got time. I think I'd rather just fix it because this will improve. This should improve any compression that are a mix between like English phrases and not. It might be like, I think we ran into this like non-breaking space. Doesn't Huffman let you store the characters as 3 bits if you want, 18 bits if you want? Yes. So what the Huffman thing, and I just closed this file, didn't I? So what we're looking at is the one, so here, word wrap again. So it is trading off these are the words, these are the sequences that we want to store, and then these are the individual sequences and characters. So like support is being encoded as, and I think the second number is the occurrence count, and then this is the actual binary representation that we're storing it in. We're storing, right, this is the decode table, correct. So the strings themselves have the Huffman coded versions, which is what all these ones and zeros are for each character. But we need someplace to look it up. You know, I was wondering when suddenly French became the problematic language instead of German before. Exactly. Exactly. So that might have been the tipping point, is when we got some character. Like we can, now that we know where the print comes in, we can say max ord. If max ord actually, you know what we want, or if ord C is greater than 255. We could pretend print text. Max ord. So this will just tell us what it is. And if you're working with Q strings, don't assume that it's going to... I'm just curious to see how much space we'll get back. Oh, look at that. I should probably print it as a comment. But there's the problem. The C compiler is worried about it too. What is this, octal without anything? Multi-character character constant. But yeah, when doing Q strings, just clean every time because I don't think we have our build rules set up quite right. Keith says, is this a fix that will go into MicroPython as well? I'm not sure because the MicroPython has done string compression, error string compression, just like we have, but they've done it a different way. They don't share the same compression technique that we do. So it's up to them to see if they have this problem. LZW on Q strings. Well, so these are not Q strings. These are error strings. These are error strings. They're not Q strings. The Q strings are not compressed still. So that we have one of our oldest issues. Down with 8859, long live UTF-8. I agree 100% with you, Kyle. Okay, so now if we open this file again, we can see that it's this translation, which if we want to, I'm curious to see how much space we're losing just because of that translation. So let's go to the French file, find that translation, and just delete this line. Or maybe what I do is it looks like a fancy quote, single quote. So let me clean now. Oh, look at that. We got like 550 bytes back. That's enough for me to pass. So now it's interesting. Now it's 73 words. And the nice quote is general punctuation. All just to have a nice quote on one thing. But we should be able to have it in there and not cost everything else. Like we should be able to figure out how to make it actually just store it as UTF-8. And then I don't need to change the translation. Okay, so I was going to pull up the build file gen header, compression generated. Let's just make this print nicer first, shall we? So compression generated is type def here. So these are file rights, but there's a missing. Let's just put 2. And then we could wrap this. But let's do another. So first and foremost, I'm just trying to pretty this up. When I'm doing, when I'm editing this script, I kind of just like to put my debug output in the script itself. See, so if I don't do a clean, it is redoing something, so maybe it will work. Oh yeah. So it did regenerate it, which is handy. W length count. So now we're back to mchar is a unit 8. Which we should always want. Let me just find C string Unicode. I was just looking at a good reference for this. C string Unicode literal. I'm in Unicode land. I'm not leaving. The Pi folder is shared between both. That's why I asked. Yep. Just like us, just like me, we like to do things our own way. This is what I was thinking of. Okay, so here's the syntax for string literals. So what we could do, instead of having this be a unit 8, what we could do is we could have this be a string literal, a U8 schar sequence, and then we'd be able to read it, which would be awesome. So being able to read the words would be awesome. And then the UTF-8 encoded string literal, the type of U8 is a const char of n until C++20. And then since C++20, it's a const char 8 tn, where n is the size of the string in Unicode code points, including the null terminator. A code point. Is that right? We're not using C++ 11? Oh, I guess C++. That's right. I'm looking at C++ string literals, not C, aren't I? Does that mean that C doesn't do that? Character literal. Maybe we do have to just encode it ourselves? Delimiter. String literal. constructor functions. That's not what I want. Oh, before C++11, there was no literal for C++ strings. Where do I find about C literals? Does it just work? C string literal. Can I find a reference just for... This is the C++ reference. Is there just a regular C reference? Ooh, Embedded Artistry is a great blog. Characters arrays, which is terminated by a null character, are called string literals. C arrays do not track their own size. I could try to find my K and R. We could add a check to Weblate to not allow characters above 0xFF. Like, that's not going to work. Like, we have Korean. Like, we have languages that are not below 0xFF. I think we have Korean. I want to support languages higher than that. Working with C strings is not intuitive. I mean, does it work? I guess it won't, because it kind of complained to me already. Comparing strings. I mean, that's okay. We can still do it. Accessing characters. All right, I don't care. I don't think we need to get it the right way. But if we do single quotes, we could do a single character. I don't know. Okay, so here's what we're gonna do. Values type is gonna be UN8 always. We're gonna get rid of this. Bits per code point. Wait, where is this used? Bits per code point. Estimated net savings. Like, that doesn't need to be broad. That can be... Okay, so we don't use it elsewhere. S must be the string. 24 is the overhead. So this would really be the length of encode UTF-8. Right, like if we're actually going to store it as UTF-8, but we're going to store it as encoded without the null terminator. I have no need for Unicode in my Swedish translation, so if I used it by mistake, that would be an error. I mean, that's fine. If you want to add a check for a given language, but my point is like, it shouldn't cost 500 bytes to store a fancy. It shouldn't. Time to start the Rust rewrite. I'm waiting for somebody to make a CircuitPython module in Rust. That would be awesome. That's where I think we should start. Okay, so here we go. That means that we can get encode doesn't include a null terminator. Does it not? Python hello.encode. That's an important thing to know. You are correct. Okay. Thank you. Thank you, Christian, for correcting me. Okay, so I can get rid of these two things. And max word. I don't use ord C. So this loop, we don't need the max ord stuff, but we do need end unused. Hi, John Franco. And don't forget to multiply by 8 where you remove the bits per quote point. Right. I understand what you're saying here because I was multiplying it by, this is in bits. Okay. So I think we removed all that. So that is all the computation to figure out which one's best. And then we don't need the type def. Our values are always going to be uint8t. So values must be the table of individual characters. This is the problem, is that a value might be more than one character now. But what is lengths? There's lengths and then there's word length count. So this is printing out for each word in words. I don't think we need for C in words, because what we can do in for C in W encode UTF-8. Would word length count be the sum of all word lengths? Like half a year ago when I poked around here, I don't trust my initial thoughts. I'll figure it out. And then this is, do we have B taken? B for byte. convert it all to. And then, you know what we can do? We can do, say, fwrite this, and then join all the words together and encode them. Actually, that's just, we just fwrite that, I think. I guess we're printing it out in a different file, but let's see what that does. This probably won't build. It takes exactly one argument. Yeah, I'm not printing. It is nice that it's rerun. So I guess what I'm thinking is, like, it's treating this as two separate sections, right? It's treating it as I thought we put it behind a... Did we print out a backslash or something? Oh, we printed a new line. Well, you know what we can do? We were just talking about this. We can repr it. And then we're going to have to go in and... Oh, you know what? Let's... let's not call it encoded. All words. And format length of all words encode. Okay. So this should fill it out so that it can tell us how long it is, which is nice and convenient. 480. Parentheses matching. All right, this should, that looks better. So now what we have is a big long thing, but we're not printing a new line. Ugh. So we need to print a new line so that we get our words down on a new line. And this other error is in supervisor shared translate. Supervisor shared translate. Line 45. Get word. mchar. Put UTF-8. Get word. Entries in the words table are guaranteed not to represent words themselves, so this adds at least at most one level of recursive call. Huh. What does... What? Entries in the words table are guaranteed not to represent words. Put UTF-8. Well, that's just because it's not... If words start... Right, so put UTF-8 is saying, given this character... But if we're actually getting a word that... The word itself is made up of Unicode characters. Buffer is a char star. So I think... Oh, we're returning size. Length. Huh. Entries in the words table are guaranteed not to represent words themselves. How does that make sense? Get word. Buffer position. What does get word do? It gets where it is, and then from that start to the end, we read the value and we put it, but the value is an int u. And therefore we add it to the original buffer, which we're not mutating at all. I think that word length count of I. Like, it's just filling in more than a single character. Right, like, I think this would all be... This is all simpler. Word start, word end. Is this because you're going from the start to the word end, but you're looping such that the position is less than the end of the word so that you can never have the full word in that loop? Yeah, present throws me for a loop though. I mean, it's really funny that it's reading. So like put UTF-8 is doing a conversion from a multi. Hi, AT makers. Like put UTF-8 is converting a number that's greater than 8 bits potentially, right? So this really should be, well, no, it's an int 8 because put UTF-8 is also used probably somewhere else. Put UTF-8. Yeah, so this is also the thing that is doing the decompression. So here's the decompression, blah, blah, blah. We tell it how many characters we filled in based on the value. And what, by calling put UTF-8 again recursively, is it's basically saying how does it work for how does it work? I don't know. Like so 7F is like 128, right? So it passes the first two through, but then does it have to like make it higher? Like that doesn't seem correct to me. Like what I would expect is it would say, oh, so if we're in the regular compression, we just pass it down. I don't know why this is int. Put UTF-8 is doing values. Search length plus bits minus max code. Values. Values. Word start is 128. Word end 200. So we get a value out. Are there... Maybe what we should do is sort this by ordinal. Like, okay, 173 means this word. 138 means 2 parentheses. I kind of want this list. Like, this list is sorted by, like, least to most. But I'm curious if there's actually holes. Length count. Values. Right, so there's like 2 steps to it. Is that right? Oh, I'm in the weeds. Like, I don't think there's any reason. Like, I don't think it's correct. I don't think it's correct for words to include, like, characters in the range between. Right? Like, does anybody know that, like, couldn't we incorrectly decompress this then? Values. Maybe I need Jeff. Jeff has looked at this too. Values. Well, I think there's an extra indirection after. I think it's Huffman to value, value to character. Character to, or it's Huffman to value, value to something. Right, like, let's see. So we have W length count, we have words, we have values, and we have lengths. So I think there's an explanation up here. I might know French and they all look correct words, but I have no clue how they get encoded. Yeah, there have been a couple of folks that have gotten in here since I did the initial Huffman version. Yeah, encoded bytes to Huffman. Encoded bytes use Huffman to get values, and the values look in the value lookup. Yes, and then the value lookup either points to a single character. Value points to a single character, and then it either points to a single character or it points to a thing out of the range of characters, which means it's a word. But that word might be a single character. So for text and text, end unused. Max words is end unused minus 0x80. Like, this feels like there's gotta be some holes in it, right? A single character based on a bit flag. Yeah, it's using the highest bit as a bit flag, essentially. Codebook, bit length. Times the number of time a word appears. What I don't get is that words changes size, but like both values. So values was always, no, values could, like, there's no bit flags being set here. Values, words. Length count is the length. None. For W in words. If length of the word equals L. Length count. So between min length and max length. Are you ever worried that the decoder is going to run out of RAM? I don't think so. Like, the decoder should be pretty straightforward. Like, I think when we're decoding a string, we know up front how long it is. So we can allocate the memory for the string at the start, and then we're just copying into it. I don't know. I'm over time, folks, and I'm in the weed, like deeply lost, and it's 4 o'clock on a Friday. So I think I'm going to wrap it up and file an issue instead of... It would really, you know, maybe I'll do what Christian, I think it was Christian suggested 2 hours ago, is I'll just change those apostrophes and file an issue. I think I'll do that, actually. Is that bad? Is that bad of me? Sometimes you just gotta walk away and think about it. 100%. 100%. Okay, let's do that. So let me back out my changes. I'm going to take a screenshot and say, or let me file the issue here first. If all the other French messages had bad apostrophes, go for it. Harold says, file an issue and have a good weekend. Sleep on it. Thank you. Yeah, that was the only one that had it because I changed it and I got 500 bytes back. Here's a pro tip if you don't want to go through the form. Never use the nice apostrophe. Relations with 2-byte Unicode characters shouldn't use 2 bytes for every character. Wow, that's a long title. Thanks, Sadie. Scott and ladies and gentlemen. Okay. When any character that is compressed is 2 bytes, and all characters in the values and words tables would be 2 bytes. Instead, only the multi-byte character should take multiple bytes. Let me take a screenshot. That'll work. This change caused the French version increase Two fancy quotes, apostrophes. One phrase. Okay. Should I call that a bug? I'll call it an enhancement. And tooling. Supervisor. And do it long term, but probably worth doing sooner rather than later. All right, so we filed the issue. Now let's use Sublime Merge to unblock myself. So this is what we're going to keep. We're going to keep this locale French PO change. That's what gets rid of those characters. And then all of this stuff that I was doing to make QString data, I'm just going to discard. I don't know that code well enough to haphazardly do it. So that's what I want. And I'll just do a quick clean make. I mean, I wouldn't be surprised if like Jeff knew about this already. Ooh, cute. The one that should be used is B4. I don't know how to input that. An apostrophe unit test. I'm really bad at... I mean, I would like to see, because I imagine that if we look at the table for other translations, like, if we look at locale, like we have both Japanese and Korean, and those are both going to take, like, what if I make the Japanese version and then look at that file? So like it's uint 16 again, and yeah, sure, there's this one and this one that are high, but like these three, 1 2 3 4 5 6 7 8, like a number of these are not as high. Like a number of these are a single byte still, so like it wouldn't be quite as good, but like actually how long is that? Yeah, so that's interesting. They're mostly above value. So I think this values thing must just be single characters essentially. And I suppose that maybe it's because I don't know what length is, but like maybe they don't have variations because then they can offset into it, or they can index into it without having to worry about where they are. I don't know. This doesn't make a lot of sense to me, which is why I'm punting. Okay, well, this should free me up. Use simple in French. Error message to save space. I mean, it's pretty wild to me that like Japanese and Korean builds are okay, but French is not. Now we can get into USB stuff. Yeah, we can chat more on CircuitPython dev. I'll probably actually be at my computer some more. I'm just like ready to stop talking. But yeah, maybe we'll do USB stuff next week if people want that. USB is always around. Um, I could maybe I could quickly nerd type Seattle people. So the project that I'm not working on for work is called campaign funds. Campaignfunds.org. We have an election here in Seattle in 2 months or so. And so this is a reformulation of all of the campaign contribution information for for Washington State. So you can see there's if you want to see like who the top donors to this candidate are, you can click it, and it's slow, but it will give you back. So now you can see like who gave money to who, and like in the last few days who gave money to somebody. And if you want to say like, oh, like what about this person, like you can see where they work, and you can click their name, and then you can pull up their most recent donations. So I'm getting very much into data sciencey land late at night. Yeah, Bruce S says, oh, now I remember, only business black funds are hidden. Yeah, it varies a little bit, but like you can actually, generally it's through political action committees, but donations to political action committees are generally reported as well. So if you look, like there's this Washington Education Association PAC. That's nice. Good space for visualizations as well. Yeah, I was playing around with that. The challenge that I've been thinking about so far is like matching people up, because their names and addresses and stuff are like they vary slightly. So that's what my brain has been thinking about, is like, how do I do data cleaning? It's my partner's a data scientist. She was just like, you're just doing data cleaning. That's all you're doing. I was calling it record linkage, but so yeah, if you want to see that, it's campaignfunds.org, and I do have GitHub Tannute campaignfunds.org is where the code to do it all is. If only we could get that kind of funding for education system. Yeah, Tiger Byte. I mean, this is why I was really interested in it. Is I'm trying to get ahead of the game, right? Because we have an election in 2 months. And then also the people that are currently elected made some decisions around. Yeah, sorry, I didn't mean to talk politics, but I guess I am talking politics. I wish we could just have people represent us for what's right and what we need, not to have schmooze people. Yeah, so it's really interesting. One thing that Seattle is piloting is publicly funded elections. So we get these democracy vouchers, and then we are able to give them to candidates, and then that gives them money. And that's accounted for in this data. So I actually want to start showing like what fraction of this money in here is like democracy voucher stuff too. I mean, I brought it up. It's campaign stuff. It's fine. We're not talking about individuals. We're talking about the system. But yeah, so I was doing all this broadband work, right? And we saw in Washington some of the representatives make poor decisions. And so I was kind of like, why are they making those decisions? And generally the money is probably why. So I wanted to get more insight into, like where the money was coming from. And we're lucky, Washington State at least has really good, it has really good reporting requirements. So I could just download this file, and not only does it have contributions, you can see like contributions, but it also has like all these expenditures, right? So this is actually like, this is a PAC. So who is the PAC donating to? Like they're donating to Schaefer for Schools, right? So like once I link this up, I'll be able to like click here and say like, oh, you got this money from this PAC. And you can do like aggregations and stuff too. So that's that, and it's all data set behind the scenes. So if you want to see the raw data, you hit all expenditures, and it's slow because it's like kind of one server behind the fact. But now it's like data set. It's the raw data from the state, and including links to like the record at the state level. And then you can also do all sorts of SQL queries on it too, which I think is neat. So yeah, I that's what I've been really sucked into is I want to make like kind of profiles for people and packs and stuff so that you can like it's kind of like Facebook for campaign finance. It's a here's this actor in this system. Where are they giving money? Where are they getting money? That sort of stuff. Um, but yeah, nothing's perfect. And in fact, yeah, I have to email them about some error that I found this morning or last night. Trying to look at like I was trying to look at like what the most popular address is to get donations from, and there's one address in Olympia that's given or gotten like 88,000 um 88,000 donations from it from all different names. There used to be the site which showed all the board members and how they were linked. I could see the donators linked that way. Exactly. Yep, you're right there with me. I would love to be able to see like like here's all the donors that give to all of the same people or give at the same time or all that stuff. Making this stuff more visible to common people is really honorable work. Yeah, so there is like it really is building on like what the state's doing. So you can dig to it at all the states, but I don't know what this is. Like statewide, like there's this system and it's not particularly easy to navigate, and it's not definitely not easy to definitely not easy to like to click from one thing to another. um so I just downloaded it in bulk and put it in a SQLite database, and but yeah, I don't know. Like you have to find like a particular campaign. Reporting, not raising any money. King County council member. Like the data's there, it's just not like not that well, not that available, I guess is what I would say. If I click Kathy Lambert, I can see all like the data about it and I can see contributions, but like I can't go from like contributor name to see who they've are like how much total they've contributed into whom. So yeah, I'm playing around with that. Like they do have contributor by category, which is great, but I would like to break down this individual category more by like how much per individual, like all these $1,000 people versus like $500 people. Anyway, I'm pretty in the weeds in that, getting my data science on. So if I know some folks actually live in Washington like I do, so I thought I'd just try to nerd snipe them. Talking about one other nerd sniping thing, going back to the broadband stuff I was doing, I filed a public data request to the city of Seattle because all of the poles are owned by the public electricity utility, and that's where all of the like cable companies and stuff put their stuff. So I filed a request for their records of everything attached to all their poles. So I'm hoping to be able to actually just determine like better availability of all that stuff. So yeah, I paid $1.25 to get it, and so they should send it to me today or tomorrow, or not tomorrow but Monday. So I'm very interested to look at that data too, and I think I'll just, as long as they don't put it under conditions, I'll throw it up on GitHub as well. Yeah, Freedom of Information Act is very cool. It just takes time. I'm learning that. I'm learning it takes more time, but I'm like waiting to see what the data is before I make more requests. Okay, that's enough non-Adafruit work. I did want to plug it. So check this out. Let me know what you think. Potentially, if there's folks in other states and you know where to get this data, we could apply it to other states as well. A lot of the mechanics of like how to aggregate stuff together will be shareable, I think. But yeah, I've been nerding out about campaign stuff, and I need to push a new version because I made these a little bit prettier. Anyway, okay, that's it. Let's wrap it up. It's been one of the more longer deep dives, so let me go back to nerd. I'm proud to be a nerd. Thank you, everybody. This has been a deep dive with Scott. We've talked a lot about a lot of things, and I'll probably have to add more time codes here because I did a very bad job today. So maybe I'll add some more after the fact. I wish anybody could add them after the fact. That would be great. If you want to support me in Adafruit, go to adafruit.com. Purchase something there. They pay me to do these streams. They pay me to work on CircuitPython and do all this stuff. So thank you to them for that. And if you want to join us and chat more, the Discord's a great place to do that. You can go to the Discord by going to the URL adafru.it/discord. Check that out. And next week should be on Friday, as always, I think. Doctor says I've spent like a third of my salary on Adafruit, and am I an employee yet? Not quite. It's not how it works. Me from my grief of hard drive trouble. Fun seeing you struggle. We've all been there. Yeah, no problem. I don't mind struggling. I actually had a lot of wins. Like this USB thing I didn't talk about was like, I was very worried it was going to take me forever, and then it went pretty quickly yesterday. So I'm feeling good. Anyway, let's go to CatCam since he's up here, and we will talk to you on the Discords and see you next week. I'll just disturb him.
Sleepy kitty.
All right. Have a great weekend, everyone.